Hello, I am Ganeshkumar, Assistant Professor, Chemistry, SNS College of Engineering. Today we discuss a case study on corrosion. The case study is the electrode flow monitoring in steel mills reduces corrosion and extend usage life. So the electrode which we use in the steel mills have been continuously been corroded because of the improper usages. And the case study is how to improve their life cycle and reduce the costs. So here the challenge is the graphite carbon-based electrodes are used for melting steel in electric arc furnace of most mini mill shops. The electrodes are the critical part of the steel making process, particularly the carbon-based electrodes. These carbon-based electrodes can transfer a large amount of current and convert it into a heat, which it is used to melt the scrap metal. So in order to melt the metal, we need a lot of heat. That heat is supplied through an electrical current, and the carbon graphite rod supports for this. But the electrodes are consumed during the melting process as they produce an arc to generate heat. When the heat is generated, we know that to melt the steel, we need more than 1000 degrees Celsius. And while melting, the heat generated during the process consumes the electrodes. So the improper electrode cooling causes. So there is another process that we can cool the electrode by supplying water. But the cooling is also when they consider in a particular industry in USA, particularly in North Carolina, the improper electrode cooling causes an excessive wear and shortness in the life of electrodes. This case happens in North American steel mill. It was an experience in high usage rate of the phase one electrode, that is a carbon graphite electrode, which increases the operation cost. As the issue was related to only one of the electrodes, because we do a lot of electrodes, but particular issue was related to the graphite carbon electrode used to produce an electrical hot and heat to melt the steel. So in the phase one, the particular issue was analyzed in this area. And the mill inquired the engineers' staffs about the improving the electrode cooling flow monitoring system. So it was suggested that a database can be tracked, a cloud storage management database system can be stored, which was already in use for the other applications of the mills. So that is already in use, but based on the data, they couldn't able to arrive at a conclusion. So how to manage this one? So the customer felt that a better understanding of the cooling water distribution could help to mitigate the issue and reduce the production cost. So we can't replace the electrode. The only choice is the carbon graphite electrode so that it can produce a high electrical heat, high electrical current can be produced. And there is no replacement for that. And the only solution is to consider with the cooling system. So they felt that the cooling water distribution should be managed properly. And the solution was arrived in such a manner. So before proposing any kind of chemical treatment, so we, that particular company, has conducted a study with the steel mill engineers to evaluate the cooling water flow control to each electrodes. Each electrode contains spray rings with very small openings that distribute cooling water into an electrode surface to provide proper cooling water coverage and optimum heat transfer efficiency. So the spray pattern requires a specific amount of water designed to minimize sidewall oxidation and electrode. So the mechanism which you are seeing in the picture is a typical example. There is a spraying method continuously applied to an overall electrode so that the electrodes can be easily uh, controlled without any wear and tear. So the system was very effective, and the corrosion of the carbon-based graphite electrodes has been reduced drastically in this case study. And the outcome, the result of this particular method, which saves the electrode life about 24%, and it gives a total saving of $155,000 per year for the company. So this is an extraordinary achievement just by changing the water spraying method in the electrode cooling. Thank you. We'll meet in another case study.